Today's webinar, hopefully, it's not going to be very long because the whole point is to show how managing your workflows in design with your product design and manufacturing collection is real easy with AutoCAD, Inventor, basically with the collection, right? Um, Basically, what we're going to be talking about is how the life cycle can look on and actually on the program, right? Because we usually think about pro life cycle management as a series of steps, right? You can get your customer input. Then you go through a process of concept development. You can go and start working on the design. There are some people who start with the design right away instead of thinking about what they actually need, right? But eventually, you get to a solution. You go through a process of creating prototypes, doing experiments, going through simulation, and then you get some feedback. You go to manufacturing, and through the whole process, you're always dealing with information back and forth, right? Uh, some result from the simulation might imply that something on your design wasn't right. You need to change something on your design. You realize that even the concept it's not going to work, right? So you gotta go back to your concept. You gotta go try some manufacturing technique to see if the product can be manufactured. You find out you can't. You go back to design. It's a matter of going back and forth, right? And managing all of that information can be a hassle, right? If we're talking about reality of the situation, something can even start with a drawing in a napkin, right? You're in lunch with a customer, they go ahead, take out their pen and start drafting something. They say, okay, I want this, and that, I want these requirements. Maybe they send an email, you get that email, then you start working on your design. You get a concept from AutoCAD, then you gotta send that to your design team. So you start sending a file via an email. Your design team starts working on an Inventor. Then turns out that the concept wasn't right. They need to resend the file. It's a whole problem, right? You need to start sending information, and you can lose that information. Okay, you can get lost in translation. Maybe the information from an email isn't right, or maybe my development team was looking at some old email, right, and looking at the right files. It's a whole hassle. Okay, so a very common thing that happens with industries is that they just send that information via email. The files are completely disbanded, right? You gotta re-import AutoCAD files into Inventor. You gotta export your Inventor designs as step files, then send that to manufacturing. The people from the manufacturing team, if they're working with Fusion or Mastercam or whatever it is they're working with, they need to import those files. Then you need to update those files. It's a whole mess, right? But here is where your manufacturing design and manufacturing collection comes into play, right? To help you streamline this process, right? So all the files that you get are going to be you're not going to get one file, of course, but all the process will be streamlined and all the files are going to be related together. So that's what we're going to do right now. We're going to suppose we're getting a requirement for a PCB design, right? And we're going to take a look at how we can import that into Inventor, how we can send that to Fusion. So all the process is kept in one single line. And if I need to change something at some point, everything is going to be linked. Okay, so we're going to start with something real simple. From AutoCAD, maybe we got something like this, right? Maybe this is something that customer sends, right? Maybe they send this as in a PDF, as a regular drawing, right? And our development team basically define that we need to create this PCB with this contact points right here, right here, right there. It needs to anchor to the case in this location right there. And this is roughly the area that we need for our PCB, right? So very simple design, very common, right? And we need to define how we're gonna do that, how we're gonna send this to Inventor, okay? So now I'm gonna pretend I'm part of the design team. I'm working in Inventor, and I'm gonna insert that design into Inventor, okay? So the old-fashioned way or the regular way of bringing in stuff with Inventor, most of the people might do, or on other software packages, would be to import the DXF, right? Would be to include that information from AutoCAD, right? Something like this, right? Or maybe what they do is something like this. They import the PCB like that. I'll give it a minute, so everything's going to be imported into a new part. Right? And now I got a bunch of entities in my Inventor design, right? I can make use of them, of course, right? I can create a quick version of the PCB if needed to, right? But the problem with this approach is that basically I'm just bringing in my entities from AutoCAD, right? If my original file were to change or something, all of these entities are no longer good, right? I would have to re-import this, basically start my design all over again, right? So instead of doing this, importing your regular entities, we can use a different approach, okay? From Inventor, what we're gonna do is we're gonna import this as a regular file, okay? So instead of hitting from the file menu, we're gonna go to the Manage tab, and we're gonna import it from the Insert tab, Insert panel, okay? This is gonna be good not only for AutoCAD files. We can also import other types of files, for example, step files or neutral type of files, IGS, those kind of things. And if the original file changes, I will be able to see those changes reflected in Inventor as well. Okay, so for example, I'm going to import it right here. Okay, and now this file, it's linked to my original file in AutoCAD. Okay, so say we're going to do something real quick here. We're going to pretend that I'm going to create an extrusion first. I need to create a sketch and project my TWG geometry. Little too thin. There we go. Right. I'm going to create another sketch in here. Project TWG geometry. This one, and that one. Context. There we go. Right. And the beauty of it is PCB version 2. There we go. The beauty of it is that now my part, it's looking into the original DWG file, okay? So if I go back into AutoCAD, I modify my PCB, let's say my customer changes his mind and they say, okay, you know what? This needs to be a little shorter like this, okay? Maybe this this entity right here, this hole needs to be at a 45-degree angle like that. We change our mind, we change our idea. Basically, we change the whole thing, right? I'm gonna close this one, and I'm gonna go back to Inventor. Inventor knows that that file in AutoCAD was changed, and I can just go ahead and update. There we go. Right? I can achieve that by simplifying my work in one single stream flow. Right? Now, I can make use of AutoCAD this way. I can also make use of our super package tools. Inside of Inventor, if I want to go ahead with a more complex with some steps further down the road on the manufacturing cycle. For example, doing simulation, for example, going into manufacturing, I can work with all of that inside of Inventor with the product design and manufacturing collection. Inside of my environments, I will have access with regular Inventor to my stress analysis module. Okay, so for example, I can create studies to check how this is going to behave, right? I'm going to create one real quick here. Design a material, write material in PVS plastic. Going to add some fixed constraints. Going to add some force that I can apply right there. Maybe 0.1 pounds should be good. There we go. Right, and I can go ahead and simulate this feature. Of course, running the simulation right now could take a little time, so we're going to keep it in there. The point here is we can do all of that in one single location, okay? Now, if we want to do something a little bit more complex, for example, we want to analyze thermal dissipation, or we want to analyze model analysis, nonlinear materials, I can work with my Autodesk Inventor master environment, okay? All of that, it's going to be integrated inside of my Inventor environment like this, right? I can create a new study, a new analysis, for example, for normal modes, right? Options, type bonded. There we go. Constraints here, here, and there. Little constraint. There we go. Right. Well, I need to do a little more setup to run this analysis, but I got all my features in one single location. Okay. Same for my my manufacturing environment. Okay. So if I want to go into CAM, I can work with CAM inside of Inventor. I can create my toolpaths. I can create my processes. Basically, I can work with do the whole process in one single location with Inventor. Okay. All of these tools are going to appear depending on what I have installed in my computer, right? So regular Inventor, it's going to look roughly like this, but without some of these tabs. For example, you won't be able to see the CAM tab, okay? But if you're part of the manufacturing collection, all you gotta do is go into your Autodesk account. this one up here. And check on your products and services. Okay, so you'll have access to all the tools from the design and manufacturing collection. So basically all of these ones right here. Okay, so with collection, you will have access to Inventor CAM. When you install Inventor CAM, you'll have access to this little tab right here, where you will be able to set up all of you have access to the tools for the CAM environment, creating toolpaths, managing machines, tools, tool libraries, all of that. Okay. Same for the nesting environments. Same for the nesting environments. Okay. We already did a webinar where we explore of those tools as well. Okay. But the whole point here is to explain how we can access those tools and showcase how everything is part of one single streamlined process with AutoCAD, with Inventor, and with Fusion even. Okay, so for example, in there are some tools that are very particular from Fusion that are not available in Inventor, such as generative design. An example of that would be something like this. I'm going to suppose that I want to create I want to do something a little more complex. Okay, I'm not going to think about how my PCB is going to go. I'm going to define the problem by specifying what needs to be done. So basically, what I got right here is my PCB design, right? I'm going to update this. And I'm going to define some areas in Inventor for my design. In this case, I have my original PCB design like this, right? And I'm going to specify this as my contact points. This needs to be present in my PCB, right? This holes right there for mounting should be present as well, right? So some material should be present around my holes as well, right? Same for this contact point right here in the middle, okay? Maybe because I updated my my drawing, this changed as well in here, so I'm gonna modify it a little bit. So this is gonna be my pressure point, basically where I'm gonna place a button or something like that. Right? And I'm going to specify as well that my design calls for a non-touch area. Basically, the circles right here are for specifying the regions I cannot touch. Okay, so basically, in this case, the PCB is supposed to be mounted on a cell phone, or maybe this is for a sensor or something like that, and the sensor requires this region right here for mounting. Okay, or maybe I got some magnets here, or in general, I have something that cannot be touched. Okay. And I'm going to define all those areas like this. All right. And what I need to define now is, okay, I need to design the PCB that includes all of this material, right? All of that, and that avoids this material, okay? And I'm going to let my Fusion artificial intelligence to figure out how that's supposed to be done, okay? So I can save my design. Right, I'm gonna save it with a new name so it doesn't mess up the one that I already had. And it's just a matter of going into your Fusion tab and sending this to your structural component generative design. Okay, this region right here is gonna act as my initial guess in some sort of way, right? So all I gotta do is click on this little button and go through the Fusion interoperability wizard. Okay, I'm gonna upload that into my team. In this case, my team is called JD Team. I'm gonna save it in my webinars folder, and I'm gonna launch Fusion as soon as I do that. Gonna give it a sec. And while Fusion loads, notice that inside of Inventor, there's going to be a little folder here called Fusion Exports. Okay, so that means there's going to be a design in Fusion right there. Okay, that's going to be created when I export it. And there's going to be a link between the Fusion file that I just created on the cloud and my original file in my computer. Okay, so if I were to change something in my design, say I need to modify my exclusion areas, right? Or maybe my customer made a change in my original CAD file, on my concept file, okay? So that will update right here in Inventor, and then I can go ahead and upload that into Fusion again as a new version, okay? So everything is streamlined. Everything's part of one single process. Real simple, real easy, okay? So now on Fusion, I can make use of all the advanced tools that I get from regular Fusion or from your Fusion extensions, okay? For example, in this case, I'm gonna make use of my Fusion simulation extension. That one includes my generative design feature, okay? So I can go ahead and create a generative design study where I keep this, that, and that, right? Where I specified that, I get some obstacle geometry right here. Where I specified that I'm gonna use this shape as my starting shape, right? And where I can set some constraints, for example, fixed constraints in my holes right here, load condition for the bottom right there, 5 newtons, like that, a little too much, 2.5. All right, and I can set advanced features, design criteria. In this case, what I'm asking Fusion is to minimize the mass for my PCB design. All right, and I want to specify that I need a maximum deformation in the Z direction of 0.5 millimeters. Right? Maximum deformation in X and Y, it's not going to be a whole issue because, well, the force is mainly driven in the Z direction. Right? And I'm going to evaluate my design for creation in additive manufacturing, that's 3D printing, and in milling for a 3-axis. I'm going to add 2-axis cutting as well in case I want to create or purchase a PCB, blank PCB, right? And make the cuts with a 2-axis cutting machine. Right, I'm going to specify the types of materials that I want to use for additive manufacturing. I'm going to specify big plastic. No, that's a little too much. Real scene. Now on 12. Go. And for my milling, I'm going to specify aluminum. Yeah, let's test how metal PCB should look. And I'm also gonna, Fusion Tool Lab. There we go. And I'm also gonna evaluate this in ABS, for example, and with L66. and ABS. There we go. All right, and I'm gonna change a couple things here. Thickness of 2, in tool diameter of 2 millimeters. Of course, going through the whole process of what we're doing here, it's can take a long time, right? So we also have other webinars where we talk about alternative design in Fusion as well. This hidden, there we go. Now we're set for generating our PCB design, right? In this case, if I run the generate, or if I generate my study, this is going to take about an hour or so. So we're going to check on some results that we already got right here, okay? So this one was already in place there. Right, so I got several solutions right there for my PCB design. If I want to minimize the mass, I can do things as complex as this one, for example. Right? Or if I want to keep it simple, it could be something as simple as this. Right? From Fusion, I can do evaluations of my solutions, right? If I want to evaluate my safety factor against my mass, check on my solutions, right? And if needed, I can use my Fusion environment to go ahead and create manufacturing paths, export these designs if needed. I can go ahead and create a design from my outcome, right? I can create a mesh design for my outcome. If I want to create a 3D printed design, I can export the solution data to CSV as well. Basically, all the functions that I got from Fusion. And it all has been done in with one single software package, that is the Product Design Manufacturing Collection, right? And everything is like, I got the information linked from AutoCAD into Inventor into Fusion as well, okay? Of course, it's not like you have to do that in one computer, right? Some people might be experts in the Fusion side or the manufacturing side. So you can make use of all the collaborative features that you get from the collection as well. For example, using Volt, for example, sending the design into the team. This is by default, right? So if our stakeholders, co-workers, whoever wants to check on this design on my JD team should have access to it as well. So it's all integrated in one single environment. So I guess that's basically what I wanted to show you guys. I don't know if there are any questions.